Hi students, welcome back. So this is our lecture number 9 of the chapter Carbon and its compounds. So this is the last lecture of this chapter. Here our first topic is about importance of carbon compounds and ethanol and ethanoic acid. Now see some important carbon compounds for ethanol. It is liquid at room temperature. It is commonly called alcohol. Ethanol is an active ingredient of all alcoholic drinks. Because it is a good solvent, it is also used in medicines such as tincture iodine, cough syrups and many tonics. Lastly, it is soluble in water in all proportions. So these are the few properties of ethanol. Next is the reactions of ethanol. First with sodium. So when sodium is reacted with ethanol, it gives sodium ethoxide plus H2. So this is the chemical formula for sodium ethoxide. Now balance the reaction. Okay, next we will see the reaction to give unsaturated hydrocarbon, that is dehydration of ethanol. So from the reaction here you can see that on heating in presence of an excess of concentrated sulfuric acid, ethanol gets dehydrated to give ethene and there is a release of water, right? Okay, next see the oxidation. Carbon compounds can be easily oxidized on combustion. In addition to this complete oxidation, we have reactions in which alcohols are converted to carboxylic acids. So from this reaction, you can say that the conversion of ethanol to ethanoic acid is an oxidation reaction. Here, the oxidizing agent is alkaline potassium permanganate plus heat or acidified potassium dichromate plus heat. So it is an oxidation reaction because say in ethanol there are 6 hydrogen atoms, but after conversion to ethanoic acid there is only 4 hydrogen atoms. Since there is since oxidation involves removal of hydrogen atoms, so it is your oxidation reaction. All of you clear? Okay, next we will see the properties of ethanoic acid. So it is commonly called acetic acid. It belongs to a group of acids called carboxylic acids. 5 to 8% solution of acetic acid in water is called vinegar. So used widely as a preservative in pickles. It is also used in food preparations. Its melting point is 290 Kelvin. And the frozen acetic acid is called glacial acetic acid. Alright, next see the reactions of ethanoic acid. First, esterification reactions. So esterification means it is the process of combining an organic acid with an alcohol to form ester. So see the reaction here. We can see that ethanoic acid, it is an acid and the alcohol here it is ethanol. So it gets converted to ester. Okay, now see the formation of ester. Here the test tube containing the reaction mixture is heated inside a beaker containing water in it. So this is the formation of ester. Alright. So our next topic is saponification. It usually refers to the preparation of soap. Now see the reaction with carbonates and hydrogen carbonates. This is the first reaction with carbonates. When ethanoic acid is reacted with sodium carbonate in presence of sodium hydroxide, it gets converted to sodium ethanoate plus water plus carbon dioxide. Now balance the reaction. Okay, now next see the reaction with hydrogen carbonates. When ethanoic acid is reacted with sodium hydrogen carbonate in presence of sodium hydroxide, it gets converted to sodium ethanoate plus water plus carbon dioxide. So guys, these are the two reactions with carbonates and hydrogen carbonates. All of you clear? Now next we will see ester plus alkali. Here in saponification, the reaction takes place in 2 steps. First one is hydrolysis of ester and second one is reaction of acid with alkali. So ester plus alkali, it gives alcohol plus sodium salt of carboxylic acid. Now first see the hydrolysis of ester. Here the ethyl acetate, which is an ester, in presence of sodium hydroxide. Here the water present in sodium hydroxide is used for the hydrolysis of ester. The H plus ion and the OH negative ion is added to the ester. So it gets converted to ethanol plus sodium acetate. Now next see the reaction with an alkali. Here the sodium hydroxide plus ethanol, it gets converted to sodium ethanoate plus water. Okay, now see the saponification reaction. When the ethyl acetate, that is an ester, is reacted with sodium hydroxide, it gets converted to sodium acetate plus ethanol. Next is the last reaction of saponification. When vegetable oil plus sodium hydroxide is reacted, it gets converted to soaps plus glycerol. And I already told you, saponification usually refer to the soap forming reaction of a base with a fat or a grease. So clear everyone? So our last topic is soaps and detergents. Now see the definition of soap. A soap is the sodium salt or potassium salt of a long chain carboxylic acid. Now see the structure. This part is the hydrocarbon chain containing 17 carbon atoms and 35 hydrogen atoms. And this is the ionic end. So the formula is COO minus Na plus. Next is the definition of detergent. A detergent is the sodium salt of a long chain benzene sulfonic acid. And this is the structure. So see here, this part is the hydrocarbon chain containing 12 carbon atoms and 25 hydrogen atoms. So the formula is C6H4SO4 minus Na plus. I hope everyone is clear. Next we will see the actions of detergents in hard water and soft water. But before that, let us know what is hard water and soft water. So hard water are those waters that contains large amounts of minerals like calcium and magnesium. But in soft water, they contains small amounts of minerals like calcium and magnesium. Alright, now let's see. In soft water, ladders form easily in soaps. But ladders do not form easily in hard water. So here ladders means it is foam white bubbles type. And in soft water, ladders form easily in case of detergents. And in hard water also ladders form easily in detergents. Next, see, in soft water no scum is formed in case of soaps. But in hard water, it reacts with Ca2 plus and Mg2 plus ions to form insoluble precipitate called scum. So scum is formed in hard water in case of soap. But in detergents, no scum is formed in soft water and in hard water. So scum means a layer of fruit or dirt. So now two samples of hard water are taken. So see here, these are the beakers. So this is sample X and this is sample Y. Now we will pour some detergent in sample Y and we will pour some soap in sample X. Then we will stir it. See here. So after stirring, we can see that in sample Y, ladder is formed. But in sample X, we can see that scum forms. Right? This is ladder and this is the scum. So we can say that after observing it, ladder forms in Y but not in X. So what we can conclude? We can conclude that detergents form ladder even with hard water, while ordinary soap is wasted due to formation of scum. So for sample X, the soap is the sodium or potassium salt of an organic fatty acid. It reacts with the hard water forming scum, hence ordinary soap is wasted. Clear everyone? Have you got the reason? Now see for sample Y, they are the sodium salts of alkyl sulfonic acid group, that is SO3H, instead of a carboxylic group, that is COOH. Now see the differences between soaps and detergents. So first point for soaps is they are biodegradable, whereas detergents, they are non-biodegradable. As you all know, biodegradable means it is capable of being decomposed. Now second point is soaps are not suitable for washing in hard water, whereas detergents are suitable for washing in hard water, as we have already studied in the previous slide. Now see the third point, soaps are relatively weak cleansing action, whereas detergents, they are strong cleansing action. Okay guys, so these are the differences between soaps and detergents. So next is soaps and detergents. Micelles. Now see, this is a soap molecule. You can see that it has a hydrophilic end and a hydrophobic end. So here the hydrophilic means they are attracted to water molecule, whereas hydrophobic means they are not attracted to water and they are repelled by it. Now next is the formation of micelles. So in molecules of soap, it constitutes the sodium salts of a long chain carboxylic acid. So in case of soaps, the carbon chain dissolves in oil and the ionic end dissolves in water. So the soap molecules form structures called micelles. Clear everyone? This is the oil droplet and these are the sodium salts. Next we will see the effect of soap in cleaning. This is grease or dirt, and when the soap is dissolved in water, it has hydrophilic end and hydrophobic end, right? So, in cleaning, the hydrocarbon tail attaches itself to oily dirt, tend to lift off from the dirty surface and dissociates into fragments. So here the hydrophobic ends attach themselves to the dirt and remove it from the cloth. But before that, it dissociates into fragments. This gives an opportunity to other tails to stick to oil. Now see here, the solution now contains small globules of oil surrounded by detergent molecules. The negatively charged head present in water prevent the small globules from coming together and form aggregates. Okay, here the small globules of oil is formed and it is surrounded by detergent molecules. So the negatively charged heads that present in water prevent the small globules from coming together and form aggregates. Okay, thus the oily dirt is removed from the object. I hope everyone is clear. So thank you guys, this is all about the lecture of carbon and its compounds chapter. So guys, if you want to do the live classes, you can download our app Nakhyatra from the link given in the description box. There not only you can do the live classes, but also you can watch the recorded classes. To clear all your doubts, you can also interact with me directly. Thank you.